Today, we will be comparing two points of view. Both points of view in this debate, sadly, result in the same outcome of girls in the classroom being shortchanged on opportunities, creating a disparity in mathematics between genders. Although more recent findings have found that gender has no bearing on mathematical knowledge and skills, teachers' attitudes and perceptions in the classroom tend to still favor males, give them more attention, and push them more than females in mathematics. Today, we will unpack the disparity in math achievement within gender with the focus on an older, increasingly outdated viewpoint, and a second viewpoint that was born from the lingering attitudes and perceptions of viewpoint one. In our society, gender distinctions are pervasive. These encompass not just physical and psychological disparities, but also entrenched societal stereotypes. Such gender-based issues, as highlighted by Ridgway and Quarrel 2004 and Risman 2004, have profound implications for our children's education. There's a striking lack of female representation in mathematics-oriented fields. Brandel and Staber 2008, Leeper et al. 2012, Steffens, Jelinek, and Nowak 2010. These gaps aren't biological, but are often born out of societal preconceptions that undermine girls' abilities in mathematics. These stereotypes often unintentionally seep into educational practices and parental perspectives, subsequently influencing children's mathematical achievements, self-assurance, and attitudes. Guterson, Ramirez, Levine, and Balak, 2012, and Nosak, Banaji, and Greenwald, 2002, Tomasetto, Alperone, and Cadino, 2011, and Tracy and Lane, 2006.
In today's discussion, we're delving into two different perspectives on the gender disparity in mathematics. One viewpoint attributes the gender gap in mathematics to inherent cognitive differences between males and females. Proponents of this theory argue that these distinctions naturally predispose males towards mathematical reasoning, leading to the observed disparities. On the other hand, some argue that gender disparity in mathematics is a societal construct rather than the result of inherent cognitive differences. Advocates of this perspective point to research revealing little to no gender disparity in standardized math tests. Despite similar performance levels, perceptions of ability can differ significantly. For example, in a recent study, when teachers were asked who was stronger in mathematics amongst boys and girls with similar math assessment scores and comparable behavior profiles, the teachers overwhelmingly cited boys as being better. These biases can start as early as kindergarten and become ingrained by third grade. Critics argue that these societal and educational biases discourage girls from pursuing mathematics, leading to their underrepresentation in math-related fields. Our objective today is to dive into these contrasting viewpoints, explore their implications, and examine the supporting research. This will help us understand the root of the issue and how we can effectively address the gender disparity in mathematics.
Gender stereotypes often form rigid perceptions about what individuals of a certain gender are like, or how they should behave based purely on their gender. Take, for instance, the stereotype that girls are naturally inferior to boys in math, or that girls are more risk-averse than boys, and even the notion that mothers should sacrifice work for child care. These stereotypes significantly shape women's and girls' preferences and expectations. It's the deeply rooted societal beliefs about the role of women, rather than biological differences, that have been identified as factors that largely contribute to the gender gap in mathematical attainment. Giso et al. 2008 and Nullenberger et al. 2016. Moreover, these societal expectations can also dampen women's motivation to excel. The lower performance of girls in math might be the result of girls internalizing certain stereotypical behaviors, especially when the task is strongly associated with gender, such as mathematical assessments, Neardarely 2017 and Iberi and Ray Beal 2019. These stereotypes can limit choices even for those who don't internalize them. One study suggests that teachers harboring implicit gender biases about girls' abilities in math tend to guide girls towards less math-intensive subjects, diminishing their confidence in the process. Carolina 2019. A growing recognition in the field of economics suggests that stereotyping behavior is often a rapid and unconscious process as much as it is slow and deliberate. Bertrand et al. 2005 and Kahneman 2011. What's more, this implicit stereotyping is found even in scenarios of perfect information, where parents and teachers should ideally have a good understanding of their children or students' abilities. Alessina et al. 2018 and Bassi et al. 2021. Whether it's because girls receive fewer resources when they pursue male-dominated subjects like math, or they internalize these gender-biased preferences, the ultimate result is that girls are often nudged towards gender-appropriate subjects, or perform worse in male-dominated subjects. This cycle of reinforcement needs to be addressed as we strive for gender equality in education.
Our journey begins before the 20th century, when education, including mathematical education, was heavily gender segregated. The majority of women were excluded from any sort of formal education, including mathematics, largely due to the entrenched societal norms. Moving into the early 20th century, societal norms started to shift and we saw women beginning to gain access to education. However, it wasn't all progress. There remained a prevailing belief that men were biologically predisposed to excel in fields like math and science. Fast forward to the mid-20th century, the post-war era ushered in a period of change, and we saw a surge in the participation of women in a variety of fields, including maths, yet stereotypes were tough to break. Despite their achievements, women mathematicians often found themselves battling to earn respect and recognition in their field. Progress continued into the late 20th century. Gender equality made significant strides, with more women entering the workforce and academic fields. This was a period when research started to challenge the preconceived notion of a true math gender gap. The math world started to realize that there were little to no innate cognitive differences that could account for the underrepresentation of women in math-related fields, yet breaking the stereotypes and biases remained a challenge. In the early 21st century, our understanding of the relationship between gender and mathematical ability underwent a seismic shift. Landmark studies proved that girls around the world were just as capable as boys in mathematics. The focus then started to shift from inherent disparity in mathematics to societal factors that may contribute to the perceived gap. Today, we have more nuanced understanding of the societal influences that contribute to the perceived gender gap in mathematics. We recognize that stereotypes and biases play a significant role, and there is a need to address these. There is a growing commitment to fostering a more inclusive and equitable learning environment in mathematics. As we examine this timeline, we see a story of progress, of an evolving understanding of gender in mathematics, but it's also a story of ongoing challenges. We must recognize that stereotypes persist, and women in math-related fields still face biases and barriers. As we move forward, it's incumbent upon us to continue debunking these stereotypes, promoting equal opportunities, and creating a space where everyone, irrespective of gender, can excel in mathematics. As we examine this matter, it is important to remember that the intersection of gender and mathematics has always been subject of significant research and intense debate. Over time, many stereotypes have emerged implying that certain genders might naturally be more predisposed to math. These misconceptions, which were largely unfounded and biased, have been substantially debunked by numerous studies. In the present day, our overarching goal is to foster an environment of equal opportunity in math education, free from any form of gender bias. We aim to ensure that all students, irrespective of their gender, have equal chances to thrive in the field of mathematics. This calls for us to address and eliminate any existing disparities, biases, or prejudice practices in our classroom, curriculum, and teaching methodologies. The focus is to create a balanced learning environment where one's gender does not determine their prospects of succeeding. So, as we proceed with the discussion, bear in mind that our end goal is achieving this balance, ensuring equal opportunities for success in math for all students, irrespective of their gender.
Recent studies suggest the underperformance of girls in math can be linked to a heightened aversion to competition. Iribarri and Rabiot, 2019. Intriguingly, research indicates girls tend to outperform boys in tests across the board, particularly when the stakes are lower. Asmat et al. 2016. These findings provide us with crucial insights that could guide the design of assessments, helping to reduce gender disparities in performance that arise from factors unrelated to actual ability. In terms of policy interventions, it's critical we start early. It's about preventing children from subconsciously adopting gender stereotypes. Some of the strategic interventions we can consider include the following: encouraging the presence of female role models in math, such as women math teachers; ensuring the use of gender-neutral language in our teaching; hosting after-school programs such as GEMS, or creating math Olympiad groups for girls; selecting textbooks and instructional materials that challenge rather than reinforce gender stereotypes. By implementing these strategies, we aim to create an environment that fosters both confidence and competence in math for all students, regardless of gender.